What is up, everybody, and welcome to my YouTube channel. My name is David, and in this video we will be asking the question, what is a switch? Now, this video is intended for individuals who are basically fairly new to computer networking and don't have pretty much no knowledge of anything in regards to computer networking. So this is just basically a beginner's tutorial video for individuals who would like to get their feet wet in the network engineering world, or should I say the network engineering field. So with that being said, let's go ahead and let's ask that question. What is a switch? A switch is a network device that resides at the access layer, and basically the purpose of a switch is to provide end-to-end user connectivity. In other words, PCs, laptops, printers, wireless access points, and etc. are connected to these switches. You basically want to be able to communicate with other devices or users on the network. That's basically what a switch do. It allows that communication to a certain extent. But anyway, let's go ahead and get back into it. So if you work for an organization or enterprise, your access layer switches, they're typically in your wiring closets. And with fiber connection, they connect upstream to your layer 3 switches. But we'll talk about layer 3 switches in another video. But anyways, to get back to the topic of what is a switch, that's basically what a switch is. A switch basically provides end-to-end user connectivity. But a switch does more than just providing end-to-end user connectivity. It has to store information. And it stores information using this CAM table, which is called the Content Addressable Memory Table. And what that does is, let's say if PC1 would like to send data to PC2, well, once this switch receives PC1's data frame, it's going to look through the frame, it's going to save PC1's MAC address, the port is on, the VLAN is on, and the type rather was learned automatically, meaning dynamically or statically. Chances are you want to have the switch learn MAC addresses dynamically, unless you have a server or something like that that's really never going to move and you want to just assign that statically. But really outside of that, you really want the switches to learn devices, via dynamically. But anyways, again, like I said, as the switch receives the data frame, it reads the source MAC address of the network device, and like I said, it maps the port number, the VLAN, and all that other good stuff, and it stores the information again, like I said, in the CAM table. And by default, it saves that information in the CAM table for 5 minutes. Now, if it's 5 minutes of inactivity, let's say PC2 was to shut down, and there's no activity, what the switch would do is it will remove that information from switch 2, and it will remove it out of its CAM table. It will basically get rid of it. And if a switch has no idea on how to get to a destination MAC address, meaning it doesn't know how to get to the destination address that the source needs to send its data to, what the switch would do is it would send out a broadcast message. And the broadcast message, within the broadcast message, I should say, the destination address is all F's. It's all F's. And what it would do is it would send that message out to every port on the switch, except, and this is important, except the port where the data frame was received on. That's what the switch does by default. And once that PC responds back by saying, oh, this is me, what this switch would do is it would then send that data out to the destination address, and it would also save that host information in its CAN table. Well, let's go ahead and jump into the switch and let's see for our own self. Let's see with our own eyes, I should say. So we'll go ahead into this switch, and we will do show MAC address table. As you can see, this switch, it doesn't have the MAC address of the two computers. And let me minimize this and let me open up laptop 1. And what we'll do is, to get things started, we're paying from PC 1 to PC 2. And as you can see, I've given PC 1 the IP address of 192.168.1.1 with a subnet mask of 255.255.255.0. So let's go back to the config, close that out, go to command prompt, we'll maximize this, and we'll do ping 192.168.1.2, which is PC2, and let's see what happens. Now we sent out an ICMP response, and we received the ICMP reply back from PC2. And let's just go ahead from PC2. Let's ping PC1 as well from PC2. Right, we are paying 192.168.1.1, and we're getting replies back, as you can see. Okay, let's go back to the switch, the command line of the switch, and let's see what happens. Let's look at the MAC address table. Show MAC address table, and there we have it. And matter of fact, let me actually pull up PC1. I actually maximize this. I come back to switch 1. We'll lower this a little bit, but I make it large enough where it could be seen as well. The information that we need to see. There we go. It's the MAC address table right here. It's gonna go away once I click on PC1, but we'll do an IP config /all. And here is the MAC address of PC1. This is the entire MAC address right here, but we'll read off the last 4. 689 BS and Bravo. We'll come back to switch 1 or switch whatever, and here we have it. 689B. We see that the switch did exactly what it do by default. It saved PC1's information. It's basically letting us know that from the MAC address table that PC1 is in VLAN 1. Here's the MAC address of PC1. I've learned this MAC address of PC1 dynamically, and is hosted on interface fast Ethernet 0/1, and the same for PC2. PC2 is in VLAN 1. The MAC address of PC2, we've learned the MAC address of PC2 dynamically, and is residing on fast Ethernet 024. And we can go to the switch and do a show VLAN brief. And there we have it. Fast Ethernet 01, which is PC1, right there, is in VLAN 1. And Fast Ethernet 0/24, which is PC2, is in VLAN 1 as well. But let's just extend on this lab a little bit. Let's just create a VLAN right quick. VLAN 2, we'll name it HR. Exit. Mode access. We basically telling this port, we basically telling FA 0/1 that is an access port. Switch port access VLAN 2. And this command is basically saying, okay, I'm going to put this interface into VLAN 2. That's all it's saying. We'll do a shut down the port, and no shut. And then we'll do the same thing with Fast Ethernet 0/24. Switch port, mode access. We're basically saying this is an access port. Switch port, access, VLAN 2. We're basically saying we're putting you in VLAN 2 as well. Shut, no shut. get out of there. And let's do show MAC address dash table. And because I did a no shut on the ports, the information that it had earlier, which was right here, has been erased. So what we'll do is we'll come to PC1 and ping PC2 again. And let's see what happens. And there we have it. Now, you never want to see a request timed out, but we received this request timed out because of ARP. It sent out a ARP response, and then they got ICMP replies back. And let's see here. Let's see if they allow me to do this command. It's an invalid command. I think it's show ARP-A if I'm not mistaken. But we'll go back to this switch and let's see what happens. No show up, so we'll just do show MAC address dash table. Huh. Let's do this then. Show VLAN brief. Okay, fast Ethernet 0, 1, and 24. Both of these ports are in VLAN 2, which is the HR VLAN. I was able to ping from PC1 1.2. Alright. Let's go to PC2 and let's ping 1.1. Okay, I'm getting ICMP replies back. So let's go back to the switch. We'll do a show IP interface brief. Okay, fast Ethernet 0, 1 is up. Do that again. And fast Ethernet 24 is up. Let's see. Show MAC address dash table. And there we have it. That's weird. When I pinged from PC1 to PC2, this switch should have saved this information, but this is a network, simulator, so things like that happen. Now, if it wouldn't have showed up again, I would have just went to the interfaces and just did a no shut. I would have just went back to the basics of troubleshooting and just bring down the interface, and bring the ports back up. But anyways, as you can see, and we can actually do this. IP config /all. Here's the MAC address 1 Charlie 5 8. And as you can see, there it is. PC2 is in VLAN 2. The MAC address, as we can see, 1 Charlie 5 8. The switch learned the MAC address dynamically, meaning learned it automatically, and that this PC is hosting on fast Ethernet 0/24. So we can see that the switch, it stores the basic information that it needs to send data between these two devices. But if I was, let's say, to either shut down these interfaces, or let's just say I don't send any pings for the next, well, it's been less than 5 minutes now, but a little less than 5, probably maybe 3 minutes from now, what the switch would do is it will remove this information out of its MAC address table until one of these PCs try to communicate with one another again. So that's pretty much from a very, very basic level on what a layer 2 switch do. So guys, if you are interested in computer networking and this is the route that you like to take, I will provide links in the description box below on where you can buy a Network Plus book, CompTIA, or you can buy Cisco book, and you want to start off with your CCNA. That's what you want to start off with if you want to get into Cisco doing computer networking. You get your CCNA book. So I will provide links in the description on where you can order these books, and I will be dropping more videos as well. The next video that I'll drop will be what is a layer 3 switch. So we'll discuss and talk about what a layer 3 switch and what's the purpose of a layer 3 switch and why it's important that we do need a layer 3 switch in our enterprise environment. So again, guys, I really do appreciate you guys. If you take the opportunity to watch this video, if you made it this far, I'd like to say thank you for watching the video. Please leave a thumbs up if you like what you've seen so far. And again, I'll be dropping more content as time go on. So with that being said, oh yeah, and by the way, before I actually close out on this video, you guys can also follow me on Instagram at I am that network engineer. And what I would do is I will leave a link in the description for you to follow my Instagram page as well, so you guys can stay updated on when I'll be uploading the video on YouTube. And also, guys, subscribe to the channel as well. That's much appreciated. And with that being said, guys, I'll be moving on to the next video. A brother gotta put some food in his stomach. I forgot it's daylight. It was daylight saving time, so my mind is all over the place right now. I have to put some food in my stomach. So with that being said, I'll see you guys in the next video. Peace.